Hello class 9. Today in this video we will go through the multiple choice question of chapter 2. Now let's start with exercise 2.1. The first question is the coefficient of x in x plus 5 into x minus 7 is. Okay, first let's recall what coefficient is. Now let's take an example. Let's say 5x square plus 7x minus 10. Now this is a polynomial here. Now in this polynomial we have three terms, 1, 2 and 3. Now when we say the coefficient of terms, we mean the numerical factors of that term. Let's see what the coefficient of x square in this first term. So the first term is 5x square here. Here in this term the numerical coefficient is 5. So we say that the coefficient of x square is 5. And in the second term we have 7x. So now the coefficient of x here is 7. Now this 7 is the numerical factors of this term. So the coefficient of x square here is 5 and the coefficient of x here is 7. And now the last term, there is no variable here, so there is no coefficient for this. Now, so let's see the first one here. The first question number 1, x plus 5 x minus 7. Now this one we have to multiply first here, so let's multiply this. X into x is x square, again x into 7 is 7x. Now you have to make sure that you don't make any mistake with the sign. Now the sign for this x is plus here, you have to see the left side sign, and then the sign for this 7 is minus here, so plus minus is minus here, minus 7x. Now again with 5 into x is 5x. Now this is plus plus, so this will be plus here. Again 5 into 7 is 35. Again the sign for this 5 is plus and the sign for this 7 is minus, so plus minus is minus. Now there is like term here, we have like term, this 2. So let's do plus minus here. Minus plus is minus, so you will do minus. So 7 minus 5 is 2x. But here this minus is this 7 is minus here and this 5 is plus here, so this 7 is greater, so we have to write the sign for this 7, so that is minus. So this is minus 35. Now here x is in the middle term, x is in this middle term. Now the numerical, this middle term is minus 2x here. Now in this the numerical factors here is minus 2, so therefore the coefficient of x is, the coefficient of x is minus 2 here. So this is the right answer, that is this C is the correct answer, or 1C is the correct answer. C, question number 1, C is the correct answer, that is minus 2. Now let's see the next question, that is question number 2. Now which of the following is a polynomial? Now first we will recall what a polynomial is. Polynomial. Now this polynomial is nothing but an algebraic expression whose powers are whole number. Example, 5x cubed minus 3x square plus 10x minus 7 here. Now here we can see that the power of x here are 3, 2, 1, and you can write here x to the power 0, so we have the power here 3, 2, 1, 0. So all these are whole numbers, so that is why this is a polynomial. Now I will give you an example which is not a polynomial, example of algebraic expression which is not a polynomial. Okay, let's say 5x cubed minus 3x to the power 2 plus 5x. Okay, now here in this expression the power of x in this second term here, this middle term, is minus 2. Now this minus 2 is not a whole number, this is not a whole number. So in whole number there is no negative number, so That is why this is not a polynomial. Now let's find out which one is a polynomial here in this question number 2. Now x by 3 minus 3 by x. Now this is clearly not a whole number because x is in the denominator. Now if you want to write it in the standard form, then this x by 3 minus 3 by x, you have to write it here like this. X by 3 is 1 by 3x, and minus here x is in the denominator, so if you bring it up here, then you have to write here minus 1, power minus 1. So in this expression now, x to the power minus 1 here, so this power minus 1 is not a whole number. Now let's see the second option. Second option is root 5x minus 1. Root 5x minus 1. Root 5x. Now this both 5 and x are inside the root sign here, square root, so minus 1. So since x is inside the square root sign, so square root sign is you know that this is power 1 by 2. Let's say for example this is 3, then this means that 3 to the power 1 by 2. So here square root 5x is nothing but 5x to the power 1 by 2. Now minus 1. Now this 1 by 2 is for both 5 and x. Now the power here, the power of x here is 1 by 2, which is not a whole number, so this is not a polynomial. Now the next one is from C. Here x plus 2 by x minus 1. Now x is in the denominator, so this is not a polynomial. Now let's see the last one, that is D. X square plus 3x to the power 5 by 2 and root over x cube. Now let's check this one. D is x square plus 3x to the power 5 by 2 divided by root x cube. So this one you can write like this: x square plus 3x to the power 5 by 2 by x cube, and then we have root sign here, so into 1 by 2. So this is equal to x square plus 3 to the power 3x to the power 5 by 2 by x to the power 3 ones are 3 by 2. Now this one is, now here this x, this two expression, the base are same, which is x. Here the base is x, the base is x. We are dividing here, so the power you have to do minus, so 5 by 2 minus 3 by 2. Now you recall what you learned in lower classes. For example, we have 3 to the power 5 divided by 3 to the power 7. Now since the base are same here, 3, both are 3, then, and this one is divided sign, so since we are dividing, you have to subtract the power, 5 minus 7. So this is what we are doing here, 5 by 2 minus 3 by 2. Now this is equal to x square plus 3 to the power here 2, 5 minus 3. So this is x square plus 3 to the power 5 minus 3 is 2, 2 by 2 is now 1. So we have here x square plus 3x, sorry, here this is x here. So we have we got here x square plus 3x. Now this is a polynomial because the power here is 1 and here is 2, which are whole number. So our right answer is, so for this question number 2, the right answer is this one, D. D is our answer. D, that is this one. Now let's go to the next question. Question number 3. Root 6 is a polynomial of degree. Okay, now this root 6 you can write here root 6 x to the power 0. Now let's recall what degree of a polynomial is. So degree of a polynomial. The degree of a polynomial is nothing but the highest powers of the polynomial, polynomial. Example here, 2x cube plus 5x minus 7 x, 5x square minus 7x. Here the highest power is 3 here. This is the highest power. The power in this term is 2, the power in this term is 1. So here the highest power is 3. So we say that the degree of this polynomial is 3. Now here, this is our polynomial here, root 6, and since any number to the power 0 is 1, x to the power 0 is 1, so even if we write here x to the power 0, it is still root 6, because this is 1, so root 6 into 1 is root 6. Power here is 0, so therefore the degree of this polynomial is 0. Here the degree of this polynomial is 0. So such type of polynomial is known as constant polynomial. So example of constant polynomial 15, and this is a constant polynomial and the degree is 0. So here the root 6 is a polynomial of degree 0. So A is the correct answer. So question number 3, A is the correct answer, 0. Now let's see question number 4. Which of the following is a monomial of degree 100? So monomial is a polynomial which has only one terms. So example 5x, this is a monomial because it contains only one term here. 2x square, for example, here it contains only one term, so this is also an example of monomial. And if there are two terms, for example here 3x, then this is binomial. And if there are three terms, 5x square plus 3x minus 7, then this is trinomial. And if there are four terms, then it is called quadrinomial, and so on. So here in question number 4, the question is asking which of the following is a monomial of degree 100. So here we have a monomial here, and the highest power is 1, so the degree of this monomial is 1. In here the highest power, the power of x is 100, so that is the degree of this monomial is 100, so this must be our correct answer. So B is our correct answer. Question number 4, B is our correct answer. Root 100 x to the power 100, so this is the correct answer here. Now let's see question number 5. Question number 5, the degree of the polynomial x cubed plus 5 into x square minus 3 is, so this is given in factor form, so first we have to multiply this to find out the degree. So x cubed plus 5, and then x square minus 3, Now first we will multiply. Let's multiply this x cubed to both this number. So x cubed into x square is, since the base are same, you have to add the power. So x into x square is, x cubed into x square is 3 plus 2 is 5. And then x cubed into minus 3 is minus 3x cubed. Now we'll multiply with this. Plus 5 into x square is plus 5x square. Plus 5 into minus 3 is minus 15, because plus minus is minus. Now there is no like term here. Now here we can see that the highest power of this polynomial is 5. Therefore the degree of this polynomial is 5. So the correct answer here is 5. That is D here. This D is the correct answer. So this D is the correct answer. So 5. This is our answer. Now we'll see question number 6. Question number 6. Which of the following is a linear polynomial? Now let's again recall what linear polynomial is. Quadratic polynomial is, cubic polynomial is. Quadratic polynomial, and cubic polynomial. Now quadratic, this linear polynomial is a type of polynomial in which the degree is 1. That is, the highest power of the term is 1. Example 2x plus 3. Here the highest power here is 1, the power of x is 1, so this is a linear polynomial. We can take another example, minus 5x plus 3. Again here the highest power is 1, so this is also an example of linear polynomial. Now quadratic polynomial. Now this quadratic polynomials are those polynomials whose degree is 2. That is, the highest power of the polynomial is 2. Example here, 2x square plus 3x plus 5. Now here the highest power is 2 here, and the power of x here is 1. So here we can see that 2 is the highest power, so we say that the degree of this polynomial is 2. So the quadratic polynomials are those polynomials whose degree is 2. Now this cubic polynomial are those types of polynomials in which the degree of the polynomial is 3. Example, 2x cubed plus 5x square minus 7x plus 10. Now this is an example of cubic polynomial. Here the highest power is 3, so the degree of this polynomial is 3. So such type of polynomials are known as cubic polynomial. And we have biquadratic polynomial. So in a biquadratic polynomial, the degree of the polynomial must be 4. So if the degree of the polynomial is 4, then we say that the polynomial is a biquadratic polynomial. Now let's see this question number 6 here. Which of the following is a linear polynomial? Now let's see the first one. Here the highest, the power is 3, so this is a cubic polynomial. This is not a linear polynomial. Now here the power of x is 1 here, so this is a linear polynomial. The degree is 1 here. So the correct answer is B. So 6 correct answer is B, which is root 2x minus 9. Now let's move on to the next exercise, exercise 2.2. Now in the first question we have, which of the following is a zero of the polynomial x square minus 5x plus 6? So let's recall what zero of a polynomial is. So zero of a polynomial. Now I'll give you example here. X square plus 5x plus 6. Now if I replace this x, if I put the value of x as minus 2, then let's see what we will get here. Minus 2 square plus 5 into minus 2 plus 6. Now here we will get minus 2 square is plus 4, and plus minus is minus. 5 2s are 10 plus 6. Now this is equal to 4 minus 10 is minus 6. Minus 6 plus 6 is 0 here. Now when we substitute the value of x as minus 2 here, minus 2, then we are getting 0 here. So this minus 2 is called the zero of this polynomial. So when we substitute the value of x as something, and then if we are getting 0, then we say that that particular value of x is called the zeros of that polynomial. Now if we try with x is equal to minus 3, again let's see here minus 3 square plus 5 into minus 3 plus 6. Now this is minus 3 square is plus 9, plus minus is minus, 5 3s are 15 plus 6. Now again 9 plus 6 is 15, 15 minus 15 is 0. Now again we are getting 0 here. So we say that minus 3 is zeros of this polynomial. So now to find the zeros of the polynomial, you have learned this while doing the exercises. So one thing we will be doing here is we will factorize the polynomial, and then we can find out the zeros of the polynomial. But instead of doing that, you can just substitute the value of this one by one and see which one will gives us 0, and that way you can also find the answer. So let's see by substitution instead of solving. So we have here x square minus 5x plus 6. So let's try putting 3. Let's try putting 3 here. So you put 3 here, 3 square, we're putting x is equal to 3 here. 3 square minus 5 into 3 plus 6. Now let's see how much we'll get this one. 9 minus 15 plus 6. Now see, 9 plus 6 is 15, 15 minus 15 is 0. So when we substitute x is equal to 3, we're getting 0, which means this is zeros of the polynomial. And now, so this is our answer. A is our answer. So here, question number 1, the correct answer is A, which is 3. Now this 3 is the zeros of the polynomial. Now let's see the next question, that is question number 2. Zeros of the polynomial py, where py is equal to by minus 1, p not equal to 0 is, now we have a polynomial here, py is equal to py minus 1. So this is our polynomial here, question number 2. Py is equal to py minus 1, by minus 1. Now to find the zeros of the polynomial, you have to write here, let this one is equal to 0, by minus 1 is equal to 0. Then what you will get here is, here you transpose this 1 to the right hand side, then minus 1 will become plus 1. So here you divide both sides by b, so you will get 1 by b here. So this 1 by b is the zeros of this polynomial. So 1 by b here, 1 by b is c. So the correct answer is C. The correct answer is C, 1 by B. You can check whether your answer is right or wrong. Now let's check. See, this is the given polynomial here. Py is equal to by minus 1. Now if you put the value of y as 1 by b here, b into, instead of y you are going to write 1 by p here, minus 1, and b got, you get here 1 minus 1. Now this gives us 0. So when we substitute y as 1 by b, we're getting 0, which means that this is zeros of the polynomial. So the correct answer is C, which is 1 by b. Now we'll go to the next question, that is question number 3. Question number 3. Now in this question, zeros of the polynomial is, zeros of the zero polynomial is, so zero polynomial is nothing but 0. So you can write 0 into x, 0 into x square, 0 into x cube, whatever you want to write you can write here, but you have to, it has to be 0 into that one. So this zeros polynomial, zero polynomial, the zero of the zero polynomial is any real number. You can take the value of x as anything, you still get the same answer, that is 0. So if you put 1 here, x is equal to 1, then this will become 0, 0 into x. So this is 0 into x is 0 into 1 is 0. Even if you take 2 also here, 0 into 0x is 0 into 2, so you'll get 0 here. And even if you take 3, also you will get 0, because 0 into 3 is 0. So the zeros of zero polynomial, zero of the zero polynomial is any real number, that is C. So the correct answer is C. The correct answer is C, any real number, any real number. Now here in this question, px is equal to x square minus 2 root 3x plus 1, then p 2 root 3 is equal to, so we're going to find the value of p 2 root 3. So here the given polynomial is px is equal to, this is question number 4, px is equal to plus 1. Now this is the given polynomial and we have to find p 2 root 3, which means we have to replace x with 2 root 3. So here let's replace with 2 root 3, 2 root 3 whole thing square minus 2 root 3, here this is 2 root 3, again this x is 2 root 3 into 2 root 3 plus 1. Now this square is for both, that is 2 and root 3, so 2 square is 4 and square root 3 square is 3, root 3 square is 3 minus, here multiply the number which is outside and outside here, so 2 2s are 4. Root 3 into root 3 is 3 plus 1. Now we have here 4 3s are 12 minus again 4 3s are 12 plus 1. Now this 12 minus 12 is 0, so we have here 1. So this is the answer here, 1. So let's see which one is the right answer. B is the right answer. So B, question number 4, answer is B, which is 1. And now let's see question number 5. Question number 5, a linear polynomial may have no 0, may have 1 0, has only 1 and only 1 0, may have more than 1 0 always. Okay, now here there is one very important point you have to remember. For linear polynomial, the degree is 1. Linear polynomial degree is 1. Degree is 1. So if the degree is 1, there will be 1 0. There will be 1 0. And now for quadratic polynomial degree is 2. So if the degree is 2, then we will have 2 zeros. 2 zeros. Degree 2, then 2 zeros. Degree 1, then 1 0. If similarly, if the degree is 3, for example cubic polynomial, then there will be 3 zeros. And if the degree is 4, then there will be 4 zeros. If the degree is 5, then there will be 5 zeros, and so on. So if the degree is 10, then there will be 10 zeros. So the linear polynomial has degree 1, so the number of zeros is 1 0. There will be only 1 0. So has 1 and only 1 0. So C is the correct answer. Question number 5. C is the correct answer. Has only 1 and only 1 0. Now let's see question number 6. The value of px is equal to x square minus 7x plus 12 at x is equal to 3 is. Now let's substitute the value of x equal to 3 here. So here the polynomial is x square minus 7x plus 12. Polynomial is, so this is the given polynomial here, and we're going to substitute the value of x as 3 here. So this p, in place of x we're going to write 3, and here 3 square minus 7 into 3 plus 12. Now this is 9 minus 7 3s are 21 plus 12. Now 9 plus 12 is 21. 21 minus 21 is 0 here. So the value is 0 here. So here the correct answer is B. B is 0. B is 0. Now we'll see question number 7. Question number 7. The zeros of the polynomial px is equal to x into x minus 1 into x minus 2 are, okay, so zeros of this polynomial. So let's say here, okay, let's write the polynomial here. Px is, now since we're going to find the zeros of this polynomial, we will say here let this be 0, so which means this be 0, x minus 1, x minus 2 is equal to 0. So I will repeat again. Since we are going to find the zeros of this polynomial, we will say that we will equate this to 0 here. So let this one is equal to 0. Now what we have here is this into this into this is equal to 0. So here, supposing if we have a into b into c is equal to 0, then either a is equal to 0 or b is equal to 0 or c is equal to 0. So if you want to get 0 here, then one of them should be 0. It can be a, it can be b, it can be c, otherwise we will not get 0. So here, since we have this into this into this is equal to 0, therefore either x is equal to 0 or x minus 1 is equal to 0, or x minus 2 is equal to 0. Now this gives us here x is equal to 1. You transpose it to the right hand side, minus become plus here, and again here also you transpose 2 to the right hand side, minus become plus here. So we have here 0, 1 and 2, 0, 1 and 2. So 0, 1 and 2 is this one, D, option D, 0, 1 and 2. So the correct answer is option D, 0, 1 and 2. Now question number 8. If px is equal to x square minus x plus 1, then p1 minus p minus 1 by 2 is, okay, so let's write the polynomial here. Px is equal to, and we're going to find out the value of p1. Okay, so we're going to find out this one. So first let's find out p1. So here p1, so this is px, this is px. If we say p1, then we will replace x with 1 here. 1, 1, 1. So this one, it will be 1 square minus 1 plus 1. So minus 1 plus 1 is 0 already, and this 1 square is 1. And then again, see p minus 1, see this portion, p minus 1. So now look at this again. Here we have minus 1 here, so we will replace x with minus 1, minus 1, minus 1. So here minus 1 square minus 1 plus 1. So this is minus 1 square is plus 1, and then minus minus is plus 1 plus 1. Now 1 plus 1 plus 1 is 3. So now finally we can find out this one. Now let's put this value here. P1 is 1. See, P1 is 1. So this is 1 here, minus, and then P minus 1. P minus 1 is here. So P minus 1, this part is 3. And then we have here in the denominator 2. Now this is equal to 1 minus 3 is minus 2 by 2. Now if you cut this, you get here minus 1. So minus 1 is our answer. Now let's see where we get minus 1. Here C is the correct answer. C, number 8, C is the answer, that is minus 1. Now let's move on to the next exercise, that is exercise 2.3. On dividing x square minus 2x minus 15 by x minus 5, the quotient is x plus 3 and the remainder is 0. Which of the following statement is true? Okay, so the question is like this. On dividing this x square minus 2x minus 15 by x minus 5, the quotient is x plus 3 here, and the remainder we get is 0. So the remainder is 0, and this is the quotient, and this is the divisor. Now I will show you something here. Now let's say this is 15. Now if you divide by 3, then you will get here 3 5s are 15. Now the remainder is 0 now. Now here this 3 is the divisor, and 5 is the quotient, and here 15 is the dividend. Now from here what you can say is this 3 is a factor of 15, because this 15 is exactly divisible by 3, and 5 is the quotient here. 5 is also a factor, because this 15 will be exactly divisible by 5, because we will be getting here 5 3s are 15. And what about this 15? Now this 15 is a multiple of 3. 15 is a multiple of 3. Multiple. So what are the multiple of 3? Multiple of 3s are 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, and so on. So here see, this 15 is exactly divisible by 3, which means that 15 is a multiple of 3. 15 is a multiple of 3. So here this polynomial is exactly divisible by x minus 5, which means that this polynomial is a multiple of x minus 5. Is a multiple of x minus 5. So here the correct answer should be x square minus 2x minus 15 is a multiple of x minus 5. So this A is the correct answer. A is the correct answer. X square minus. Now let's see the next question, that is question number 2. Question number 2, the remainder when x cubed plus ax squared plus 6x plus a is divided by x plus a is. Okay, now we're going to find the remainder here. The given polynomial is px is equal to. Now this is the given polynomial, and the divisor here is x plus a. The divisor here is x plus a. So this is the divisor, x plus a. Now we will use here remainder theorem. So let's write here, let this equal to 0. Then here x is equal to, you transpose to the right hand side, plus become minus here. Now we will substitute the value of x equal to minus a in this given polynomial here. So let's substitute p minus a. Now this is what we call remainder. Now let's find out the remainder here. X is minus a cube plus a into x is again minus a, so minus a square plus 6 into minus a, and then plus a here. Now this is equal to minus a cube. So minus a cube is minus a into minus a into minus a. So this is minus a into minus is plus, plus into minus is minus. So this is minus a cube. So this is minus a cube. If the power is odd number, then you know that the answer will be minus. If the power is even number, it has to be positive number here, plus. So now again here a into minus a square. Now the power is even number, so this minus will vanish, no more minus, because minus a square is minus a into minus a, so minus minus is plus. Now a into a is a square. So what we got here is a square. Now this 2 plus minus is minus, 6 into a is 6a plus a here. So now this one is plus, so this is plus. Now minus a cube plus a into a square is a cube minus 6a plus a. Now minus a square plus a square is 0 already. Now minus 6a plus a, minus 5, since minus number is bigger here, minus 5a. So this is the remainder, minus 5a is the remainder. So this is our answer. Now let's see which is this one is given in which option. C. So C is our correct answer, C. So question number 2, correct answer is C, which is minus 5a. Now let's see question number 3. When x cubed minus 6x squared plus 9x plus 3 is divided by x minus 1, the remainder is, okay, so in the same way we're going to find the remainder, same like question number 2. So our given polynomial is plus 9x plus 3, and the divisor is x minus 1. The divisor is x minus 1. This is the divisor. So we're going to use again remainder theorem. So let's say let x minus 1 is equal to 0, and then you transpose this 1 to the right hand side, then minus 1 becomes plus here. So now we will substitute the value of x is equal to 1 here in this polynomial. So that will give us the remainder. P, instead of x we will write here 1, and this is equal to, this 1 is going to be substituted here. So this is 1 cube minus 6 into, again x square is 1 square, plus again 9x is 9 into 1 plus 3. Now here 1 cube is 1, and 1 square is 1. 1 into 6 is 6, plus 9 ones are 9 plus 3. Now let's add all the plus number here, this and this. So 1 plus 9 is 10, 10 plus 3 is 13, 13 minus 6 is 7. So the remainder here is 7. So let's see, this 7 is given in which option? 7 here, D. So the answer is D. The answer is D. Answer is D, 7. Now let's see question number 4. When px is divided by ax plus b, then the remainder is, okay, so we have a polynomial here, px. Now the polynomial is px, and the divisor is ax plus b, and the divisor is ax plus b. So here we're going to use the remainder theorem again. So let ax plus b is equal to 0. Then you transpose p to the right hand side, then this plus p now is minus p. Now dividing both sides by a, you will get here x is equal to minus b by a. Therefore the remainder is you just have to substitute value of x as minus b here. Value of x as minus b by a. So the remainder will be p. X in place of x you write here minus p by a. So this is our remainder. So nothing is given here after this, so this is the remainder. So p or minus p by a, so which is this one, b. So this p is the right answer, b, that is p minus b by a. So this is the answer. Now let's see question number 5. Question number 5. If x to the power 100 plus 100 is divided by x plus 1, the remainder is, okay, so again the same thing we're going to repeat. The given polynomial here is x to the power 100 plus 100. So the given polynomial here is, we're going to replace 1 here. This one we're going to put it here. So p, and here x is 1, minus 1. So minus 1 here, this is equal to x is again minus 1 to the power 100 plus 100. Now the power here is even number. So if the power is even number, now this minus becomes plus here. So we'll get here plus, and 1 to the power anything is always 1. 1 to the power anything is always 1. So 1 multiplied 100 times, we will get 1. So 1 plus 100. So 1 plus 100 is 101. So this is the remainder. So let's see which option gives us this 101. 101. Oh, 101. So we don't have 101, which means there is a printing mistake here. So the answer is 101. So this is 101. So we can make any of this 101. So let's make this 101. Let's make this 101. So C, let's say C is 101. C is 101. Now let's see exercise 2.4. On factorizing x square plus 8x plus 15, we get, okay, let's try to factorize this one. Question number 1. This is the given polynomial here. This is a quadratic polynomial. The highest power is 2. That is, the degree of this polynomial is 2. Now to factorize this, we will use splitting the middle term method. So now this is the middle term here, and this is the last term here. So, and the coefficient of x square is 1. So the first step is, in splitting the middle term method, the first step is you have to check the coefficient of x square and the constant term, that is the last term. So here the coefficient of x square is 1 and the constant term is 15. So let's multiply 1 and 15. So 1 into 15 is 15. So 1 into 15 is 15. Now what you will do is, you will find two numbers such that when you multiply the two number, you should get 15 here, and then always you should see the sign which is to the right of this middle term. So this is plus, So when you add, that means when you do plus the same two number, you should get here the middle term is 8. So now this is 5 into 3, 5 3s are 15, 5 plus 3 is 8. So we're going to use 5 plus 3. So here x square plus, we're going to break this, split this middle term. So 5 plus 3, 5 plus 3, x plus 15. Now here x square plus 5x plus 3x plus 15. Now pairwise we will take common here. So now taking common is nothing but dividing both the terms by the same number, by the same thing. So here we have x, here also x, so we can divide both the terms by x. So now x square divided by x, x square divided by x, this is x into x by x, so this is x. Now 5x divided by x, 5x divided by x, so you have here 5 plus, again here in these two terms we can divide both the terms by 3, so we're going to take 3 common. So 3x divided by 3, now 3x divided by 3, so 3 cut, you'll get here x. Now 15 divided by this 3, 15 divided by 3, so 3 5s are 15, so 5 here. Now again in these two terms there is x plus 5, x plus 5, so we will take x plus 5 again common. So here taking common is nothing but dividing both this term by the same thing. So here we're going to divide both this term by x plus 5. So if you divide this one by this one, x plus 5 cut, you will get here x. And now this is plus, again here also if you divide by this one, then you cut this 2, then you will get here 3. So what we got here is x plus 5, x plus 3. So here x plus 5, x plus 3, so this is the right answer. So order, it doesn't matter, you can write x plus 3, x plus 5, x plus 5, x plus 3 is the same thing. So this C is the answer, C is the answer. So the answer is C, which is x plus 5 and x plus 3. Now let's see the next question, question number 2. The value of a for which x minus 3 is a factor of x cubed plus x square minus 17x plus a is, okay, here the given polynomial is x cubed plus x square, given polynomial is x cubed a, this is the given polynomial, and x minus 3 is a factor, x minus 3 is a factor here, x minus 3 is a factor. So by factor theorem, let's say this is px, px is equal to this one. Now by factor theorem, now if this is a factor, then when you put the value of x as, so this is x minus 3, if you take this one equal to 0, then x will be equal to 3 here. So if you put the value of x as 3 here, you should get 0, you should get 0, since x minus 3 is a factor. This is true only when x minus 3 is a factor. So the value of a is 15. So let's see where we have 15. So we have 15 here in C. So this C is the right answer. So this question number 2, the answer is C. A is equal to 15. Now let's see question number 3. Question number 3. If x minus 1 is a factor of mx square minus root 2x plus 1, then the value of m is, here this question is very much similar to question number 2. So we're going to do exactly like how we did in question number 2. Question number 3 is x mx square minus root 2x plus 1. This is the given polynomial. So let's call it px. Let's call it px here, and the factor is x minus 1 here. So since x minus 1 is a factor, if we write like this, then we get here 1. So since x minus 1 is a factor, then when we substitute the value of x here as 1, then we should get 0 here. We should get 0. That is what the factor theorem says. That is, the remainder should be 0. So since x minus 1 is a factor, x minus 1 is a factor here, since x minus 1 is a factor, p1 should be equal to 0. So that is now instead of x in this polynomial, we will substitute 1 here. So m into 1 square minus root 2 into 1, root 2 into 1 plus 1. This is equal to 0. Now 1 square is 1, 1 into m is, now 1 square is 1, 1 into m is m, minus root 2 into 1 is root 2, plus 1 is equal to 0. Now let's transpose this root 2, minus root 2 and plus 1 to the right hand side. Then we will get here minus become plus here, and plus becomes minus here. So we will get here root 2 minus 1. So this is the value of m. Now let's see where is this root 2 minus 1. Now root 2 minus 1 is here in the last option. So the answer for this tree is D. Here the value of k for which x minus 1 is a factor of the polynomial. Now all these questions are 2, 3, 4, 5. These are similar questions. The only difference is that the polynomials and the factors are changed. So let's see this one. So here also let's say the given polynomial is px, and here x minus 1 is a factor. X minus 1 is a factor, so we say x minus 1 is equal to 0 and this is equal to 1. So when we substitute the value of x as 1 here, we must get 0. That means the remainder should be equal to 0. That is what the factor theorem says. So since x minus 1 is a factor, x minus 1 is a factor, so p in place of x, we're going to substitute 1 here. So px is p1 and we should get this 0. That is, the remainder must be 0. Now here we're going to substitute x as 1, here 1, here 1. So 4 into 1 cube plus 3. Now 1 cube is 1, 1 into 4 is 4, 1 square is 1, 1 into 3 is 3, minus this is plus, and minus 4 into 1 is 4, plus k is equal to 0. And now 4 plus 3, 4 minus 4 is 0, we get here minus 3. So minus 3 here, D. So this is the right answer. Question number 6 now. If y minus p is a factor of the polynomial this, then the value of p is. Now all these questions, question number 2, 3, 4, 5, 6, all these are similar questions and you have to solve it in the exactly similar manner. So this one you have to try it by yourself. So this is the end of this exercise. Now we will go to exercise 2.5. This is exercise 2.5. Now let's see the first question. On factorizing f for x squared plus 1 plus 4x, we get. So let's factorize this 4x squared plus 1 plus 4x. Now this one, let's write in standard form here, 4x squared plus 4x plus 1. Now this is 4x squared plus 4x plus 1. Now this one here, we can factorize it very easily here using identities. You can use splitting the middle term method. I'm sure by now you all know how to factorize using splitting the middle term. But now in this case, I'm not going to use splitting the middle term. I will be using identities a plus b holding square identities, which is a square plus twice ab plus b square. Here, so here this one you can write 2x square, and then you leave this middle term right here twice like this. This is a technique, and the last term is 1, so this one you can write 1 square. Now whatever you have written here you write here, and whatever you have written here you write here without the square. So now let's see whether we are getting 4x or not. So 2 2s are 4, 4 1s are 4, so we get here 4x, so which is correct. We can write like this. Now this is a square plus twice ab plus b square, so a square plus twice ab plus b square. So now this is, and this, if it is like this, then we can write like this. So this is in this form, so we can write like this. So a plus b holding square. So the factor is 2x plus 1. So 2x plus 1 holding square is here, b. So the correct answer is b. It's 2x plus 1 holding square. On factorizing 4x square plus y square plus 1 plus 4xy plus 2y plus 4x, we get, okay, these are the options. Now let us try to factorize this given polynomial. 4x square plus y square, 4x square plus, now here we can use the identity a plus b plus c holding square. So we are going to use this one, a plus b plus c holding square. So this identity is a square plus b square plus c squared plus twice ab plus twice bc plus twice ca. Now this identity is what we are going to use now. To use this identity, we will see whether the given polynomial can be expressed in this form, in this second line. So let's see whether we can express in this form or not. Now the first term is 4x squared. This one you can write 2x holding square. So this square is for both. 2 square is 4, x square is x square, plus y square here, plus again this 1 you can write 1 square because 1 square is 1, and then to make like this we will write here 2, and then we have to write in this form. So in this form we have to write. Now let's see whether we can get like this or not. Now whatever, see, this is AB, so whatever we have here we're going to write here 2x, and whatever we have here we're going to write without square, and check whether we will get like this or not. So 2 2s are 4, 4xy, so 4xy we're getting, and then again to write what to write here is we will write this one and this one. So here without square we will write this y and then 1 here. So now 2 1s are 2, now this is 2y, so 2y, yes, we're getting like this, and then the last one you have to take this one and this one, so AB, BC, CA, so twice of this one, 1 without the square, and then this one without the square. Now 2 2s are 4, 4x, now we have 4x here, so which means this can be expressed in this form, and which is this one. So now this is a square plus b square plus c square plus twice ab plus twice bc plus twice ca, so which is in this form. So we will write like this, it means a plus b plus c holding square. So this is our a, this is our b, this is our c. So we have here 2x plus y plus 1 holding square. So this is the answer. Now which options gives us this, we will check. 2x plus y plus 1 holding square. Okay, this second option, 2x plus y, or no, not this one, this one, the last one. If x plus 1 by x is equal to 2, then x square plus 1 by x square is, okay, so here x plus 1 by x is given, that is 2, and we have to find the value of x square plus 1 by x square. So it's simple, we will just use this identity. So a plus b holding square is a square plus twice ab plus b square. So we're going to use this identity. So let's see here, x plus 1 by x holding square, we will find out this one. A plus b holding square is a square plus twice a b plus b square. Now here x plus 1 by x is given, x plus 1 by x is given, this is equal to 2, x plus 1 by x is equal to 2. So instead of x plus 1 by x, we're going to write here 2, and then we have here power 2. This is equal to, now this right hand side, here this middle term we can cut x and x, so we get here x square plus 2 ones are 2 plus this one, you can write 1 square by x square, so 1 square is 1 by x square. So now let's transpose this 2 to the left hand side. Now 2 square is 4, and then we will transpose this to the left hand side, so we get here minus 2. Now what remains is x square plus 1 by x square. So we have here 4 minus 2 is 2. This is equal to x square plus 1 by x square. So here x square plus 1 by x square is equal to 2. So the value of x square plus 1 by x square is 2. So let's see which option is 2. Here the first one, so this is the correct answer. So A is the correct answer, is A, that is 2. Now we'll see question number 4. Question number 4 here is if x square plus 1 by x square is equal to 38, then x minus 1 by x is equal to, now here again we're going to use an identity here. So here it is given x square plus x minus 1 by x is what we're going to find out. A square plus b square is equal to a minus b holding square plus twice ab. Okay, we're going to use this identity in this question. So a square plus b square is a minus b holding square plus twice ab. Now here a square, x square plus 1 by x holding square, so this is our a and 1 by x is our b, is equal to a minus b, that is x minus 1 by x holding square plus twice ab, that is 2 into x into 1 by x. Now here this is x square plus 1 square is 1, x square is x square, and then here x minus 1 by x holding square plus here x and x you can cut, so you get here 2. Now x square plus 1 by x square, x square plus 1 by x square is 38, so this is 38, and this is equal to x minus 1 by x holding square plus 2. Now let's take this 2, let's transpose this 2 to the left hand side, so you get here 38 minus 2, this is equal to x minus 1 by x holding square. Now 38 minus 2 is 36, and here we have x minus 1 by x holding square. Now if you want to remove this square, then you have to write here square root of 36 is equal to, here we have x minus 1 by x. Now we know that 36 is 6 square, therefore square root of 36 is 6. So this is 6 and this is equal to x minus 1 by x. So we have got the value of x minus 1 by x, which is 6. So let's see which options gives us 6 here in this question. Question number 4. A, B. So B is the answer. So B is the right answer, that is 6. So our answer is B. So the solution is B, which is 6. Now let's go to the next question, that is question number 5. Next question is question number 5. Now the value of y minus 2x holding cube plus 3z minus y holding cube plus 2x minus 3z holding cube is, now we're going to use again an identity here, and let's recall this identity: a cube plus b cube plus c cube is equal to 3abc if a plus b plus c is equal to 0. Now this identity we can apply only when the sum of this a, b and c is equal to 0. Now here in this question we have here y minus 2x holding cube. Now this is to be taken as a, and this is to be taken as b, and this is to be taken as c. Now we will check whether this a plus b plus c is equal to 0 or not. A, that is y minus 2x, plus b, that is 3z minus y, plus c, that is this one, 2x minus 3z. Now let's see whether we will get 0 or not, this one. Now if we get 0, then we can apply this formula. So here y minus y is 0, and 3z minus 3z is 0, and 2x minus 2x is again 0. So we get here 0. So now we are getting that a plus b plus c is equal to 0. A plus b, this is a, this is b, this is c, is equal to plus a plus b plus c is equal to 0. Therefore we can apply this formula, that is a cube plus this is a is this one, a cube plus b cube 3z minus y holding cube plus 2x minus 3z holding cube is equal to thrice abc. A cube plus b cube plus c cube is equal to thrice abc. So 3 times of a is this one, y minus 2x, b is this one, 3z minus y, and c is this one, 2x minus 3z. Now this is the answer, and let's see whether this is given in the option or not. We have here 3y minus 2x, 3z minus y, 2x minus 3z. So D is the correct answer. So D. Solution is D. Okay, now next let's see question number 6. Question number 6 here. The factors of 3 root 3 x cube plus y cube are, okay, the factors of 3x cube y cube 3 root 3 x cube plus y cube plus y cube. This is this one you can write root 3 cube. Root 3 cube is 3 root 3. So root 3 cube is root 3 into root 3 into root 3. Now root 3 into root 3 is 3, and we have here root 3. So this root 3 cube is root 3. So instead of 3 root 3, we can write root 3 cube. Here, this 3 root 3 we can write here root 3 cube, and x also there is cube plus y cube. Now this is in the form a cube plus b cube. Now let's recall the formula. A cube plus b cube is equal to a plus b, a square minus ab plus b square. So this is the identity that we have to remember. So now this is a and this is b. So a plus b, then that will be root 3x plus y, and then a square here root 3x holding square minus ab, so this two root 3x y plus b square, that is y square. Okay, this one root 3x plus y, and then here root 3 square is again 3, and then x square minus root 3xy. You cannot do anything with this, we will just leave it as it is, and this one y square. Now let's see which option is this one. Root 3x plus y and root 3x square minus root 3xy plus y square. So this is the right answer, the first one, that is a is the right answer, plus y square.